Hi, welcome to everyone's favourite segment, Mailbag. Let's get into it. Unfortunately, I have opened this one, so meh, whatever. Anyway, you may know who this is from if you've watched, if you followed Lewis Rossman. He's actually interviewed the person who sent this, Eric Lundgren, if I'm pronouncing that correctly. Thank you very much, from bigbattery.com, or how you may know him formerly from, I'm not sure what company it was, but anyway, there was a big kerfuffle about him going to jail. There's actually a documentary on it. I'll link it in down below, about him actually going to jail. Microsoft, for like pirating Microsoft CDs and like recycling computers, and including a Microsoft CD that you could download from their website, or was it, yeah, anyway, I don't know the details, but anyway, interesting story. But yeah, ever since he's got out, he's formed bigbattery.com, and they actually recycle like all automotive batteries and all other, like any lithium ion batteries they can get in the industry. They actually recycle these, and they're absolutely massive now. They got their own factories where they recycle these batteries, retest them, repurpose them, and use them for all sorts of stuff. They've actually got contracts with like half of the automotive manufacturers out there to recycle all EV car battery packs. And if you don't know, I've got a Hyundai Ioniq electric car. I'm going to have to do a follow-up video on that. And anyway, it's actually been recalled. Apparently they're going to recall the Australian ones too, because, I don't know, 8 of them caught on fire or something. So they're recalling the whole blinking lot, and they're going to replace the battery packs in them. And Big Battery in the US, they're actually getting all of the ones that are being recalled in the US, and they're actually going to repurpose the batteries in those Hyundai Ioniqs to be used in the charging stations for the new Amazon electric truck fleet or something. Anyway, very cool. So these batteries aren't going to waste. And anyway, Eric's is a totally interesting story. So I'll link in the doco down below. Check it out. What we've got here, ta-da! Look at this. These are actually Tesla Model 3 batteries. Fantastic. I'm not actually going to do a teardown of one of these bad boys in the mailbag, but if you want to see me like unroll the jelly roll on one of these things, then I can do that on the EEVblog 2 channel. But yeah, this is a Tesla Model 3 2170 battery, and I've got a whole bunch of them. I'm probably going to have to get one of those, tab welding machines, so I can actually connect to these and do something interesting with them. So I've got a whole bunch of them. Anyway, they manufacture a bunch of stuff using all these recycled EV and other batteries, and this is one of their things which they made for the Indian market apparently. And yeah, it's a little portable 300 watt portable battery charging station. I've got 2 of them, so let's tear one down. So here it is. Here it's in a extruded aluminium case. It's got that kind of pinky, not really gold, but pinky color. Don't like it. Meh. Anyway, 180 watt hour capacity, 300 watts continuous output power, 450 watts peak. So you're not going to go charging your electric car with this thing. Not that 180 watt hours wouldn't get you very far. By the way, my Hyundai Ioniq gets anywhere from 10 to 14 kilowatt hours per 100 kilometers. That's kilowatt hours. So yeah. Anyway, this is not going to be a full review of this thing. Let's do a teardown. It's got a little LED display on the front showing you the capacity left, 53, 64. Yeah, I charged this up fully when I've got it, but it's been sitting here for like a month or something. So as is common with these packs, you will get some self-discharge. It's got a couple of 2.4 amp USB jobbies. This is the 240, like the more universal 240 volt, 220 volt model. We've got our AC in. Also, we've got solar charging as well, but it seems to only support 42 to 60 volts, which is a bit disappointing. This is your regular 8mm plug, which is common to recharge. Like I've got a 400 watt hour battery pack. It's got the same connector, and I've also got like a 100 watt fold out solar panel for it, but it's like only like 20 volts. It's not 42 to 60, so that's probably a bit of a fail. Don't know what's going on there. Anyway, small fan. Obviously, something's heat sinked on the side here. So, yep, more power devices. Let's open it up. I was just about to say that this is going to be a problem if we have to like take these off and slide apart the whole thing, but it looks like she might just crack open like this as that battery's on the... You have to be very careful, of course. I should have probably discharged this before I took it apart, but yeah, battery... Oh, yeah, let me get the back screws off first, but it'll just lift off. All right, now we should just be able to lift this off, and nice, that's how you should do it. Beautiful. And, of course, what we want to see is battery management, protection, all that sort of business, and it looks like... Yep, I can see lots of battery management on there. First thing I noticed is, check that out. There's a connector on there and the cables have been cut off. Why? Is that a balance thing? Like to balance out the string? Not sure. So it looks like that's all mounted on a big custom cell frame, and the individual cells are in there like that. There's 2 rows of, well, you know, however many fit in there. These are 18650s, I would be guessing. Yes, they must be, because the Tesla ones, they look a little bit too long, because they're your 2170s or 21700s, but you can take the 0 off the end. 2170 means 21 millimeters in diameter by 70 millimeters in length, and likewise 18650 stands for 18 millimeters wide by 65 millimeters long. So yeah, they're 18650. So not sure where they're sourcing those from, but all the batteries they use apparently are recycled from somewhere, and they individually test each and life cycle each cell, and make sure they're all good before they reuse them into packs like this. And then we've got our main board down here. I assume it's, I think he might have mentioned that it's custom designed by them, I think. Don't quote me on that. But anyway, yeah, that's a bit how you're doing. There's our 240 volts mains input. No insulation on that at all. And this is double insulated in quote marks, so there's no mains earth on this thing. And I don't know, is there adequate clearance between the bottom of the pins on the connector down there and that bottom of the chassis? That looks a bit tight. Anyway, what we've got, clearly, this is our main side switcher here, and there's a main switching transformer, bridge rectifier down in there. The cap is, yeah, it's a nothing burger. It's a Hincos? Never heard of it. Anyway, yeah, there's our low ESR output jobby. So there's our secondary side there. We've got an isolation slot cut out there. But yeah, like there's nothing, there's no common mode chokes or any other filtering on the primary side here. So there's just one. Is that a PTC? And they look like our primary side switches there. Then our secondary power supply, this is going over to the fan over here. It's an isolation slot right down the middle there, and then they've got the wire going over. So this is the voltage going over here to power all of your charging circuitry over here. So yeah, that goes off to our battery pack. There is a fuse. There's like a cartridge fuse down there that looks like that looks like an automotive cartridge fuse or whatever they're called. Is that soldered in? It's interesting. Yeah, I think that's soldered down. Wow. Got a TO220 flapping around in the breeze there. It's a bit how you doing. So yeah, this section is going to combine our, charge. You've got to charge the battery. You've got to charge it from your 240 volt input or your solar input, which comes on this side here. So there'd just be diode ore in that, are they? Oh, there's a little current shunt in there. Oh yeah, that could be your diode ore in there. And then we've got our sine wave generation over here. So all this is our sine wave generation. Here's our driver trannies heat sunk down there. Oh, well, we've got other ones down here as well. There you go. They've got held in place with sill pads and grease as well. Why do you need both, really? Because the whole idea of the sill pads is that they take out all the imperfections in the surface of, well, both surfaces, the transistor and the case, that you're trying to cool down. You don't need the thermal paste to get in there. So you just squish them down on the sill pad and Bob's your uncle. But anyway, they put down some thermal compound as well. Jeez. And the main on-off switch, that's just a soft switch over here. So there you go. That's why, you're going to lose some battery over time because you've got a little bit of standby power. I'm not going to bother measuring or anything. This is not a review performance. This is just a teardown. And then what's it? Oh, there's our LED display down there. So that'll be our little micro controlling our LED display. I don't know. You micro aficionados, I don't know. You can read that. I can't see it from here. And then that's probably our other controller up there for our mains generation. And, well, that's about all she wrote. There's not much else to say about it, really. But there's our mains. Yep, there's our mains output. So these four are our direct mains output switching trannies, which then, of course, goes directly out to our 240-volt out. Once again, no heat shrinking on there. Not one stuff given. Well, as it turns out, I can't actually get this out because one of the screws is like stripped down there. Like the head is actually stripped, the Phillips head. The other ones were fine, so I'm not sure what's doing there. But anyway, I don't want to cut off the insulation here, so mate, no, look, couldn't be bothered. It's just a mailbag. It's not a comprehensive review. Anyway, it looks like this board is designed for something else, I suspect, because these have got like LED outputs here. So I think they're repurposing this from some other product they make. But, it's probably got all the requisite protections and stuff like that in it, and, cell balancing, all your battery management stuff. So, yeah. So I have actually tried this thing, and it does work, but once again, not a full review, so I'm not going to bother, measuring waveforms under load and stuff like that. I don't even know if it's a pure sine wave inverter, doesn't say. Anyway, yeah. Just a mailbag. If you do want me to test something specific, I can do that on the second channel. Just let me know down below. But yeah, apparently this is designed for the Indian market, so, it's not like they've spared no expense on this thing. It is built down to a price. But yeah, I like the fact that they're repackaging these recycled batteries. They're actually reusing them instead of tossing the damn things. Good stuff. So anyway, check out Eric's website. I'll link it in down below because they're like remanufacturing like millions of these batteries, like recycling millions of these EV packs from old cars and doing all sorts of things. And absolutely, we went from nothing to like the biggest one. I believe they're the biggest battery recycler in America or something like that. Like they're absolutely huge now. Unbelievable. And there's stuff you can buy like massive, like hundreds of kilowatt hour battery packs, like for home storage. We're using all recycled cells and stuff. So, brilliant. I love seeing stuff being recycled. Absolutely fantastic. These bloody self-tappers, these are horrible. Like, half of them are bloody stripped now. Ugh. Our Workbench of the week comes from Fabian Schwartau, if I'm pronouncing that correctly. I'm sure I'm not. It doesn't say what country, but from the EU by the looks of the email. Thank you very much. And obviously, this is a RF test bench. And sure enough, these down here are 5.8 gig horns here, and we've got a directional coupler, amplifier, and whatnot. And of course, given that his name, he's got Roden Schwartz gear, doesn't he? So, unfortunately, his spectrum analyzer only goes up to 4 gig, and he's got a SIGGEN 300 kilohertz to 3.3 gig there. You can actually get, these are quite older units, you can get lots of these fairly cheaply on relatively cheaply on eBay. If you have a good hunt around. So just got some basic power supplies. Geez, I remember those ones and those ones. Yeah, classic. Looks like we've got a BK Precision electronic load up there. What else we got? We've got and of course, a Roden Schwartz yet again, European, and we've got the little, which is Haymeg. That's a dual branding one, Roden Schwartz Haymeg dual branding. If they just go in for because they kept the Haymeg name for the lower end stuff, I think. Anyway, very cute scope. We've got the Rigol dual channel function gen there. We've got some old Philips stuff. I love the old Philips stuff. We've got an old 10 meg function gen here and a pulse gen. Geez, pulse gens, they were pretty popular kits back in the day, obscure bit of kit. I built my own pulse generator. I think it only went up to a megahertz or something, or 5 meg or something. It wasn't much. Wasn't this 50 megahertz jobby. Geez, I would have drooled over one of those as a kid. Unbelievable. Anyway, we've got an FSP spectrum analyzer here. He said it only goes up to 4 gig, but it says 7 gig. Anyway, 3 gig, he says in his email, but it says 7 gig on there, so I'm not sure what the deal is. It looks like he only got one without the generator option. If you are looking for these on eBay, do try and get the tracking gen option, because it's going to be much more versatile, but he probably picked these up like really cheap. Secondhand would be my guess. And Vector Network Analyzer VNA, 4 gig jobby. Very nice. So there you go. That's not hooked up to anything at the moment, but that's a classic RF bench. Awesome. Nope, nothing else there. I'd be sure, he's probably got more like component bins and all sorts of stuff off to the side. See no soldering gear, but this is just like a testing RF testing bench. Cool. Thank you very much, Fabian. Hi to all my viewers in the Ukraine. Thank you very much, Oleg Kutkov, if it's a silent K, I think. Anyway, from KYIV, Kiev, Ukraine. I don't know. Thank you very much. Let's have a look. No, it's not a hub. It's everyone's favourite segment, Mailbag. Few people take me to task for saying it's not my favourite segment. Why do you keep saying it? Take a guess. All right, what do we got? Pull. Okay. Pull. That's it. Oh, nothing exciting happened. No explosions. No nothing. Okay. Got some capped on tape holding it on. Wonder if it's going to be new or second hand. Don't know. Mailbag's like a box of chocolates. You never know what you're going to get. I see SMA connectors. SMA connectors usually mean some form of RF-y thing. And based on the ground plane, there, I would say, yeah, controlled impedance. Look at that. Match length, is it? Yes, match length. Open source hardware. Oh, okay. It's a clock distribution thing for, time reference, like a 1 pulse per second clock distribution. You distribute it out to all your instruments. It's a lab reference. You have your rubidium frequency standard, your GPS standard, or whatever, and this distributes your clocks to all your instruments in your lab. Cool. Let's check it out. Third suck of the sav for Oleg. Anyway, here you go. 1 pulse per second propagation delay, 4 nanoseconds, 10 megahertz clock propagation delay, 10 nanoseconds. It's open source hardware and software. Apparently, I missed something in a previous video. Oops. Sorry about that, Oleg. Anyway, check out his website, and here is the open source hardware clock distribution amplifier. Really? I'll call it. Anyway, there you have it. Just basically your 10 megahertz reference in. It can be other frequencies, but 10 megahertz is the standard used in test instruments. And then 8 outputs here to drive 8 instruments all across your lab. So, yeah, if you've got one rubidium reference standard, you don't need more than one, unless you'd like doing comparisons and stuff like that. Anyway, you plug in your rubidium reference standard, and then you can plug it into your scope and your spectrum analyzer and all your other gear. Fantastic. Of course, not all gear has like an external 10 megahertz reference input, so you've got to check if your scope or spectrum analyzer has that capability. Any sort of medium to high level scope will, and analyzer will though. So anyway, 1 pulse per second control. Not sure what this jobby is here, because do we have a schematic? Aha, we have an overlay. There you go. Power 7 to 12 volts, and these are all the 1 pulse per second CMOS outputs if you need that many, I guess. So it's input, output. I'm not sure what type of amplifier is used on there. Unless we have a look at the schematic, we won't go that far, but there you go. That's neat. And as I said, trace length matched here. That's what the wiggle years in here are. Of course, what you'd normally do in this sort of situation, exactly what Oleg's done here, you'd start with just your straight one out here, because this is going to be your longest path. So you'd start with your longest path like that. Obviously, it's a symmetrical design, so this path length and that path length here matches this path length length matches, and then you add the extra wiggle years in here to get to, and of course you make them a little bit, it's a little bit out on this symmetry there. This one's sort of like, it's not going to matter a rat's ass, it's just aesthetics. So cool. Some labs will have use for a clock distribution amplifier like that. You could whack it in a custom case or something like that. That'd be sweet. Link down below. Thanks, Oleg. Got one from Australia, from Lightning Source. I don't know, from Dandenong in Dandenong South. Sorry, I don't want to insult all the Dandenong Southernians. I don't know. Is there a rivalry between North and South Dandenong? I don't know. I'm not from Melbourne. Anyway, let's check it out. It looks like it's looked like a book kind of. You know, usually ship like books in this kind of thing. So it is. We have a book. Oh. Practical Hardware Pen Testing, a guide to attacking embedded systems and protecting them. Cool. Okay. Is this considering that it comes from Australia here, is this a local author? Okay, cool. We'll have a quick skim through it. The dreaded pointer. Cool. So practical pen testing, pen testing being penetration testing, of course, a guide to attacking embedded systems and protecting them against the most common hardware attacks. Sweet. So for those who are into penetration testing by Jean George's Vale, something like that, let's go. Looks like it's brand spanking. About the author, about the reviewers as well. I'll be very brief on this, so let's just look through the getting to know hardware and stuff, small tools and equipment, renting versus buying tools. Excellent. CPU block, storage block, identifying components. Furby. Opening they do the Furby, do they? Terrific. Why C and not Arduino? Introduction to C, the stride methodology, planning your attack. And then they got all the requisite buses, I2C, SPI, UARTs, extracting and manipulating onboard storage, Wi-Fi, Bluetooth, BLE, software-defined radio attacks, accessing the debug interfaces. Usually you can find like a debug port on like a JTAG debug port or something like that. Dynamic reverse engineering. I get a mention! And the EEVblog forum gets a mention. You'll find a curated list of DMMs with their characteristics and comparisons on the EEVblog forum. Yes, you will. It's actually an incredible spreadsheet. Sorry, I forget who actually compiled it, but it's kept up to date. It's got like hundreds of multimeters. It's absolutely incredible. I also warmly encourage you to watch the videos from EEVblog. Dave Jones' style isn't for everyone, you think? But personally, I like it a lot, and his videos are always very educative. Educative? Is that a word? I guess it is. So I assume that the author is actually, because he watches my videos, and he's told the publisher, hey, ship one to the EEVblog. So I think that's how it's turned up. And then, I guess they shipped another one of theirs. Opening the Furby. So it looks like they're going to use the Furby as an example. Epoxy blobs and things, traces of the SPI stuff. This is all good stuff. Balancing your scenarios. Type of actor, kid with an Arduino and a soldering iron. Amateur, security researcher, criminal group, state actor or electronics company. Love it. Attacking the hardware. So I don't know if they have anything on like side channel attacks, like, power supply attacks and stuff like that. I mean, that might be too specific for a book like this. This seems to be like going for, sort of accessible kind of, power supply is accessible, but yeah, it's a bit more advanced. Logic voltage transitions, open bench logic sniffer, then you got your Bluetoothies and Wi-Fi's and whatnot, sniffing raw Bluetooth. Oh, they get into transmitters as well. Nice. And then there's a whole section on attacking the software and things like this. It looks pretty comprehensive. You probably should have this on your bookshelf if you want to do any sort of reverse, not necessarily like penetration testing, but just reverse engineering. So yeah, I couldn't readily see anything on like more advanced stuff like, power line injection attacks and stuff like that, but this looks like a pretty good primer. Well worth checking out. I'll link it down below. Well, we're on a roll. Might as well have another book from Brad Surleys from Flemington, New Jersey. So, hi to all my New Jersey viewers. Let's have a squiz. Good to see people still publish good old-fashioned dead tree books. Fantastic. Oh, it's a hardcover. Oh, Marvelous magnetic machines, building models, electric motors from scrap. Oh, that's pretty neat. Just got to be careful. There's no over Unity woo-woo in here, is there? I don't think so. Hang on. No, I think it smells woo-woo free. It's okay. So, yeah, I think this is just shaft and... Oh, okay. Wow. For all you motor aficionados, this could be sweet. You're standing in front of an old card table in a driveway at a garage sale. On that table is 1-quart aluminium saucepan, a votive candle holder, pieces of some office machinery, and a wooden awards plaque. What do you see there? If you did not answer a 6-cylinder radial electromagnetic attraction motor, then you need this book. This is great. Author of The Voice of the Crystal and Instruments of Application returns, this time to explore the principles behind the operation and construction of 5 simple yet impressive model electric motors. You'll learn where to find and hunt for materials and where to salvage suitable bearings. Excellent. So the whole, look, I mean, this is like, and this is what they're talking about there. They're talking about, yeah, that's obviously a saucepan. Look at that. And that's the awards plaque they were talking about. And like... building a motor from this, it's like work of art, really. And it takes you in 150 pages through designing like 7 different types of machines. So let's have a quick flick through. Oh, okay, we got our got some electronics stuff, and we've got a whole bunch of CAD drawings. Oh, some nice close-up color photos. Beautiful. Oh, fantastic. Like the motor aficionados out there are probably wetting themselves because this is gorgeous. I don't know what the Christmas motor is, but you can get the book. You can read all about it. So they're not anything practical, I guess, but they're more like building these things just from scrap for like work of art, hobby kind of stuff. The Texas motor, yeah, it's like I guess they call it the Texas motor because it looks like drilling, like an oil, an old Texas oil rig kind of thing. I guess that's what I get with the big armature up the top and the big piston going down or whatever. So, yeah, vectors and vector math. Wow. Well, that's certainly very interesting and novel. Linked in down below. Oh, hardcover. Beautiful. I think this might be the first time we've had a second suck of the sav on the same mailbag. It's from Lightning Source. And here is it. Got a bloody pull tab on it. Surely you'd have a pull tab on that. Bugger it. Aussie pull tab. There you go. No, it's another one. So they're having 2 sucks of the sav. This publishing company, yes, Pact. Learn Robotics Programming. There you go. For all you 2nd edition, not that 1st edition rubbish. Learn robotics programming for all you robotic aficionados. There you go. Creating pan and tilt code. Finding your Pi on the network. So it looks like we're using a Raspberry Pi. Building a scanning sonar. Wow, it's all happening. OpenCV, of course. Because OpenCV is like the thing for vision stuff on robots. Voice communication with a robot using Mycroft. No idea. Another quick squiz. So Packet Publishing having another suck of the sav here with Robotics Programming, 2nd edition, build and control AI-enabled autonomous robots using the Raspberry Pi and Python. Oh, Packet is searching for authors. There you go. I do actually have an open invitation with a publishing company if I ever want to write a book on engineering or anything else. But yeah, writing a book is a metric crap ton of effort, and in the end I'm actually, because I've got such a large audience, I'd be better self-publishing and promoting it myself anyway. So, but for those who don't have a large audience like mine, then yeah, a publishing company like this will get your name out there. Preparing a headless Raspberry Pi for a robot, backing up code with Git. Oh yeah, all that newfangled Git stuff. RGB strips, drive and turn, Python. It seems all, elementary, and then they work their way up to advanced stuff like OpenCV and things like that. I don't actually know how easy it is to implement OpenCV, but I've heard that, it's not too hard at all because a lot of people have worked on that and they've taken all the hard work out of it. Who's the book for? Someone with little programming experience or someone with more experience looking to apply their skills in a hardware project. You do not need to be an expert level programmer. What does robot mean? So yeah, it starts off pretty basic. controllers, PWM stuff, planning the physical robot. There you go. So it's good to give to, like, I don't know, you might give this to a young teenager or something like that who's interested in doing robots. I mean, I would have killed for a book like this when I was a kid. But then again, we didn't have like Raspberry Pis and stuff like that back then. It would have just been like a line-following robot with a couple of transistors in there as a, you know, and a photo cell, and that's, you know, like that's about as advanced as robots got when I was a kid. Yeah, lots of stuff in here, programming, wiring up sensors. So it really is, you know, it's quite a big book. It's actually lots of step-by-step. Looking inside servos, so that's really good. Absolute and relative positions, counting. Oh, we're getting into PIDs now, are we? Correcting veer with a PID. Ooh, yeah, okay, PID stuff. Excellent. I don't think they go into, they don't go into heavy detail on that. It's like just using PID programming modules or program modules or whatever to do the job, which is fine. You know, you don't necessarily have to know the intricate details of how to write, PID loops and stuff like that. You can just, use pre-written modules, magnetometer stuff, all that sort of stuff. So as you can see, yep, it's actually quite a thick book. We're talking like 550 odd pages of robotic goodness. Linked in down below. Check it out. Finally, we've got one from the United States of America. Thank you very much, Robert Alexander, from Northwood, NH. Where's NH? New Hampshire, I think. Need to check. Yeah, I think I'm right. So this is a homemade something or other, which could be interesting. Most people don't home make one of these things. They normally just buy them. All right, what do we got? Got a note. Real? Oh, wow. Wow, gone to a bit of effort. Even got like a silicon rubber outer thing. It's not as advertised on the box. It was supposed to be homemade multimeter, but obviously that's more than a multimeter. Well, it does multi-stuff, so I guess it's a multimeter. Who says a multimeter has to measure electrical stuff? This does utility, TBID, whatever that is, logic analyzer, GPS simulator, servo, PWM, UART in, UART out. Oh, look at that! UART in, UART. It's a special purpose. So, there's your PWM, and it's got like a graphic representation of the PWM signal, showing you the duty cycle and whatnot. UART in, UART out. Wow. GPS simulator. Look, it's got a world map on it. Oh, this is terrific. This is a Bobby Dazzler. The first issue is there's a 4-way pin header on this, and it doesn't, there's no key on it. So and there's no plus, no, BA, negative ground. Okay, no, it is labeled. Yep. There we go. That's cool. Really. I mean, a homemade special purpose multi-test tool. I wouldn't call it a multimeter because that's obvious. The obvious connotation is an actual multimeter. Oh no, it's called a logic meter. There you go. He calls it a logic meter. It's sort of a mashup between a logic analyzer and a multimeter. The idea is to take certain tools that you might need when developing a microcontroller-based system and make them as quick and easy to use as possible. I think this will make a great commercial product, but I don't want to do the work. I'm hoping someone will see the demo and decide to produce it. So, hey, if you're out there and you want to go into partnership with Bob, good on you, Bob. None of that Robert rubbish. Bob, then if you like this, get in contact down below. So there's Bob's letter, and yeah, I've had it for a while. Sorry, Bob, there's a lot of stuff that's been sitting on my mailbag bench for a while. And as I said, he is looking for someone if you like this, to then contact Bob. Linked in down below. I've got his email address. Well, I'll try and include something. But this is one of the coolest things we've gotten on the mailbag. It's a do-it-yourself. Look, we'll switch it on. Utility, connect the USB, and we can do help. Oh, to be determined, TBD. It's literally TBD, to be determined, unimplemented. Oh, that's great. Logic analyzer, and displays up to 3 digital logic signals. And there's the GPS simulator. So the helps. Oh, yeah, help's very simple. Oh, it didn't switch from GPS sim. Ah, is that a bug? Look, if I go help and I switch it, it doesn't immediately go out of help. I declare that a bug. But, you know, no wuckers. UART stuff, SBI in, UART in, and yep, I mean, we just have to hook it up. And PWM, this is really cool. So, yeah, period, duty cycle. So how do we, oh, yeah, arrows. Okay. Whoop. Whoa, missed a key stroke there. Yeah, you could argue that, like, this sort of resolution screen's not really needed. I mean, it's, like, the font's, like, it's really quite small on the screen. So I would say that, yeah, not particularly, you can get away with a much small, although I guess if you've got a lot of data, though, with, you know, UART and, you know, stuff coming in, ASCII data and things like that, I guess, yeah, the more display real estate, the better, perhaps. But, yeah, I don't know what to think. Like, I'm not generally a fan of a jack-of-all-trades tool. I'm more of a fan of, like, just specialized, you know, bits of kit that do that. Like, why have a GPS simulator in there? Like, how many people are going to need a GPS simulator in a product like this if you're just, you know, buying it for its UART and PWM and logic analyzer capabilities and stuff like that? Although, once again, it's software, so it comes for free, right? But the good thing is, of course, is that the schematic and source code is all available. It's open source hardware, so you can go, oh, I really like how he's implemented the, you know, the UARTs and, you know, stuff like that. Then if you just want that and a smaller LCD, you could actually just take the existing schematic and design and software and just repurpose it into a more simple specialized tool and stuff like that. So yeah, what have we got on our utility? Connect the USB to a PC for data access. Oh, okay. Oh, I didn't... Oh, yeah, there we go. USB port. Hacked into the side of the case. Nice. This is classic prototype stuff. Of course we're going to take it apart. And the thing with this sort of stuff is a lot of people don't bother building things into cases anymore. You know, with the Adafruits and the Spark Funds and all those sort of things. They're all just like everything you buy on Tindy. They're all like just bare board kind of stuff. So, yep. Oh, there's our big, yeah, one board. That's what I expected. Big lithium polymer battery in there. Oh, yep. Stuck down with a bit of Celastic. And of course, that's all you expect is a micro, because I haven't looked at the schematic. Oh, I can't even read that. What's an MZ2048? I don't know. Aha, it's a PIC 32 MZ2048. They just don't put the 32 on there. Thank you very much, Microchip. Yes, all the Microchip fanboys go wild. It's still a very powerful micro. You know, everyone's gone over to the bloody ARM micros these days, but yep, the good old Microchip architecture, still a winner chicken dinner. Although, yes, I know PIC 32 is MIPS. So yes, it should be absolutely trivial to take this existing work and then, you know, adapt it for your own use in any way you want. On the hardware side of things, though, it looks like the inputs here just straight into the micro here. So yeah, it's got no logic. That'd be 3.3 volts, wouldn't it? Is the PIC 32 got 5 volt logic thresholds? Don't know. Do have a genuine bodge wire though. Got to have a bodge wire on a prototype. One of the problems is I have no idea what B, A, and P means. Bueller? I am getting something, but the software leaves a lot to be desired. It has got auto baud rate, but I can't seem to change stuff. Clear. Oh, no. K. 9600. I'm not sure actually what baud rate I'm actually generating. There we go. I am successfully receiving data, and it just ended. So, yeah, I'm not actually sure what I'm transmitting, but it's certainly receiving stuff. And if we put it into UART out mode, it's just generating ASCII here. I've got it 9600 baud, and sure enough, Bob's your uncle. Put it in single shot capture mode. Oops, the ground's come off. Let's try that again. And start. Boom, there it is. Starts with space, and then it's going up in the ASCIIs. So there you go. If you're interested in all or part of Bob's little or do it all kitchen sink multi-tester thing, then check it out down below at galacticstudios.org, the Logic Meter. Good on you, Bob. Hi to all my viewers in Japan. We don't get many from Japan, so thank you very much, Keith Sear. Let's check it out. It's, fourth suck of the sab in the mailbag. Well, in terms of books, it is book, but there's something else in here. There's a toy as well. So let's have a look. That's our book. This is our toy. Let's have a quick look at a book. This is a book bonanza. Learn multi-platform assembly language. Beginner's Introduction to Assembly Language for ARM and 68,000 and all the rest of it. Sweet. Z80, 6502. Is this new? Or is this like just old? Don't know. No. Yep, this is his own book. He took the plunge, and it's publish on demand. This is one of these Amazon publish on demand, print on demand. So if you don't know about that, apparently, like, you upload your manuscript, you upload your print files for it, and they'll only print a copy of the book and send it if somebody orders it. So if you order one, they'll actually print one, and they'll send it to you. It's like, it's very cool. I'd love to see their system in place for actually doing that. So that's very cool. So a lot of work publishing a book. Absolutely fantastic. It's also included an Ichigo Jam for your amusement. It's a Japanese, why didn't we think of that answer to the Raspberry Pi? Okay, so it's really? Okay, it's a kit. It's a Japanese Raspberry Pi kind of sort of kit. There you go, assemble yourself. Well, we've got a build-up version. Okay, yeah, we've got a build-up version. There it is. Check that out. LearnASM.net if you want to pick up one of these bad boys. First edition 2020. And covers Z80, 6502, 68,000. So if you're into your vintage processors, 8086, that's pretty much the first one I started on was 8086, and then I only got into the others later. And then for all you ARM aficionados, there you go. So, what is assembly language? Let's have a look. Oh, I'm liking the drawings. This is pretty cool. Yep. This is nice. Did Keith do the drawings? Oh, YouTube channel as well for video tutorials. Cool. Bytes and words and long doubles and floats. Conditional computation, comments, indirection pointers, jumps and branches, graphic. Oh, it goes into your graphics stuff. So if you want to do your assembly language, like, any vintage assembly language, talking about the Sega Mega Master System and stuff like that. So, looking good. This could be a handy little reference. 6502 references, 68,000. Where do we get into the ARMs? I've never done ARM assembly language. Don't know. Here we go. All you ARM aficionados, hello worlds, where to go from here? Not a bad reference. There you go. Keith's the creator of Chicky Kumis. It explains what that is in the book, in assembly language, and I'll link in his YouTube channel down below. Check it out for tutorials and stuff. And I just checked out his YouTube channel. I can't believe he's only got 8,000 subscribers. Come on, let's get him up to at least 10,000. Maybe we can get him to 100,000 for the YouTube Silver Award. Trust me, there's some awesome content over there. Tutorials, retro programming stuff. There's just tons of it. Looks like it's very well done. Hats off to Keith. So this is what Keith calls the Ichigo Jam, but it's got SkyBerry Jam, trademark, SkyBerry Jam. There you go. It's a Japanese little computer that is like based on like 1980s computers and stuff like that. So it's not up to like Raspberry Pi standards and things like that. But yeah, look, it comes in a do-it-yourself kit. That could be it is school holidays. Maybe, with the lockdown. This could be a Sagan assembly kit, perhaps. Aha! Surface mount micro already pre-programmed, presumably, and soldered down there. That's a bit of a bummer, isn't it? Anyway, it's an LPC 1114, and everything else is basically, yes, everything's through hole, although they do have like a couple of surface mount, one surface mount alternative there. And check out the instructions here. It's in Japanese, so it's pretty comprehensive, though. Pretty impressed. That's great. I don't know what I'm reading, but of course it's electronics is electronics. What is that? Is that, yeah, that's some sort of for loop step instructions programming? Basic. So yeah, it's like one of those little basic computers which we've built up before. Sagan enjoyed building the last couple. That I think he's done at least 2 of them. So maybe we can build up another one and give it a whirl. What's the output? It just hooks up to USB, does it? Is there a actual video output? Oh, no, I think I found it. RCA jack. There we go. Surely that's composite. Yeah, it's composite video out. Nice. Would have been nicer to get like VGA output or something. So thank you very much, Keith. Definitely check out his YouTube channel. Trust me, it's a good one. If you want programming tutorials and vintage programming and gaming stuff, wow, it's very comprehensive.